Welcome back to Circuit Meter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in.
Today, we're getting into something that honestly affects almost every local government budget: energy management for public buildings and assets.
Yeah, it's a massive challenge. Think about everything a municipality runs: city halls, libraries, sure, but also pools, arenas, water treatment plants.
Exactly. And our mission today is really to understand why managing energy across such a diverse portfolio has been so, difficult, and how some new approaches might be changing the game.
It really comes down to pressure from two sides, doesn't it? You've got taxpayers wanting lower operational costs, keeping property taxes down.
Right. Huge pressure there.
And then at the same time, there are these really ambitious carbon reduction goals, GHG reporting requirements. They need to cut costs and emissions.
Which sounds almost impossible when you look at how things have traditionally worked. The sources we looked at kept hitting this one point. The utility bill is basically an aggregated black box.
Totally. You get this big number at the end of the month, but zero insight into what's actually driving it. Is it the library HVAC, the pumps at the wastewater plant? You just don't know.
So you can't really manage it effectively. It's like trying to diet by just looking at your total grocery bill.
Exactly. That's why we're diving into solutions like Circuit Meter today. They're talking about using advanced analytics to get inside that black box.
Circuit meter, right. They call it forensic energy management, which I like. It suggests digging deep.
Yeah, moving beyond just the bill to actual circuit-level data, granular stuff.
So the idea, the big promise here, is making energy visible, so it finally becomes manageable. Let's see if that holds up.
Sounds good. Where should we start? The scale of the problem.
Yeah, let's start there.
Ah.
Because it's not trivial. We mentioned the variety: community centers, arenas, pools. You've got EV chargers popping up everywhere now.
Water and wastewater plants, too, which are critical. 247 operations with huge energy demands. Managing that diversity is inherently tough.
And the cost implication is significant, right? We're not talking pocket change here.
Oh, absolutely not. Energy can be, up to 10% of a municipality's operating costs in some cases. It's a major line item.
10%, wow. And electricity is often the biggest chunk of that.
Often over half, yeah. Especially with complex systems and increasingly things like electric vehicle fleets and chargers. So if you want to control costs, you have to get a grip on electricity use.
So what have municipalities been doing traditionally? Just relying on those periodic energy audits?
Pretty much. Bring in consultants, they poke around for a bit, look at some major systems.
Which sounds expensive and, temporary.
It is. Audits are just a snapshot. They might miss things, they don't cover everything, and crucially, they don't stop what's called performance drift.
Performance drift. Explain that a bit.
Sure. So you might tune up an HVAC system, get it running perfectly efficiently, but over time, without continuous monitoring, settings slip, components wear slightly, efficiency just slowly degrades.
So the savings you thought you locked in just evaporate.
Exactly. It silently eats away at the budget, and the audit wouldn't catch that until the next extensive cycle, maybe years later.
And this whole time, you're still blind to the real drivers because of that black box utility bill. You can't even properly allocate costs between departments, can you?
Nope. Or pinpoint which specific machine is suddenly guzzling power. Or, importantly, justify spending big capital dollars on an efficiency upgrade because you can't easily prove the payback.
Okay, let's talk about a specific killer cost: demand charges. I know they're a huge pain point for commercial bills. Can you break that down?
Yeah, demand charges are tricky. They're not based on your total energy use over the month, but on the highest peak of power you draw from the grid at any one time, often measured in 15-minute intervals.
So one short spike can cost you big for the whole month.
Precisely. If several large pieces of equipment happen to turn on simultaneously, maybe a big chiller and some pumps, that creates a high peak. And that peak sets a charge that can be, 30, 40, sometimes even 50% of your entire electricity bill.
Ouch. And without knowing what caused that spike.
You're powerless to stop it happening again next month. It's the ultimate black box penalty. You're paying a huge premium for something you can't even see.
Which brings us back to needing that granular data. So, Circuit Meter, how does their tech actually tackle this? What are they doing differently?
Well, their core idea is to monitor energy use right down at the individual circuit level. Think of the breaker panel in a building they're putting sensors there, or very close to it.
Okay, so not just metering the whole building, but specific circuits feeding specific loads.
Exactly. And they emphasize doing this at a relatively low cost compared to traditional submetering, which could be prohibitively expensive to do comprehensively.
And this gives you what kind of information? Real-time stuff.
Real-time granular data. So instead of waiting for the monthly bill, facility managers can see right now how much power each significant piece of equipment is drawing.
Ah, so that's how you tackle demand charges. You can see the peaks forming.
Yes. You can see precisely which machines contribute to the peak demand. Maybe it's 2 large rooftop units cycling on together. With that data, you can then implement strategies, maybe stagger their start times or adjust thermostats slightly, targeted reductions.
And identify waste, presumably, like systems running when they shouldn't be.
Absolutely. Lights left on in an empty wing, HVAC running full blast overnight, pumps cycling unnecessarily. Circuit meter lets you spot that immediately.
Benchmark things, like know what a specific motor should be drawing versus what it is drawing.
Precisely. You can set thresholds. If a motor suddenly starts drawing, say, 15% more power than usual for no reason, you get an alert. That could be a sign of a bearing failing or some other mechanical issue developing.
So it becomes a maintenance tool, too, catching problems early.
A huge part of the benefit, yes. Identifying those energy anomalies before they lead to a catastrophic failure and shutdown, it moves you towards predictive maintenance.
And given that huge diversity of assets, we talked about pools, EV chargers, water treatment plants, does the circuit meter system scale across all that?
That's the claim, and it seems crucial. The platform needs to handle everything from standard building loads to specialized high-voltage equipment in something like a water plant, and manage it all across multiple sites.
Okay, scalability is key. The analytics platform they use must be pretty robust to handle all that data from potentially hundreds or thousands of circuits across a city.
Yeah, and present it in a way that's actually usable for the managers on the ground. Dashboards, alerts, reports, making the complex simple.
Let's touch on implementation, though. Putting sensors on individual circuits sounds potentially disruptive or complicated. Is it easy to retrofit?
That's always a fair question with any new hardware. Circuit meter emphasizes a low-cost, sort of distributed approach to make deployment easier, but I think the real key is the integration.
Integration with what? Existing systems?
Exactly. Their platform is designed with APIs, application programming interfaces, so the energy data doesn't just live in a circuit meter silo. It can talk to the building management system, BMS, that controls the HVAC, or the computerized maintenance management system, CMMS, that schedules repairs.
Ah, okay. So the energy data automatically informs other operational systems. That makes sense.
It prevents data silos and makes the information much more actionable for the teams already using those systems.
Which leads us nicely into those operational benefits, especially for critical services. You mentioned predictive maintenance. Let's explore that a bit more, particularly for something like a water treatment plant. Uptime there is non-negotiable.
Absolutely critical. For facilities like that, the circuit meter data isn't just about saving money, it's about resilience and reliability. Continuous monitoring of pumps, motors, aeration blowers.
You see the electrical signature changing if something's wrong?
Precisely. That subtle increase in power draw, or a change in the power factor, these can be early warnings of impending failure. Staff see that alert, analyze the trend, and can schedule maintenance before it breaks down.
So just-in-time maintenance, instead of just guessing based on a calendar schedule.
Exactly. You avoid the cost and risk of sudden failures, but you also avoid the cost of over-maintaining replacing parts that are still perfectly fine just because the manual says so. It's data-driven.
That risk mitigation must be huge for public services. Avoiding a water plant shutdown, even for a few hours.
Massive. Both in terms of cost and public health and safety, that continuous insight is invaluable.
Okay, shifting gears slightly to the financial planning side. Municipalities make big multi-year capital investments. How does this granular data help justify, say, replacing an old, inefficient chiller?
This is where the historical data logging becomes vital. The circuit meter platform, according to the sources, keeps up to 10 years of data.
10 years, okay.
That historical data allows you to establish a really solid baseline of energy use before the upgrade. Then, after the new chiller is installed, you can measure the actual energy consumption.
And prove the savings.
Exactly. Using what's called M&V measurement and verification. You need that verified data trail to show City Council or whoever holds the purse strings that the expensive upgrade delivered the promised savings. Without it, justifying the next big project becomes much harder.
So it closes the loop on capital investments. And you mentioned the CMMS integration earlier. That flow into this, too.
Yes, absolutely. When the energy data suggesting a potential problem flows directly into the CMMS, it can automatically trigger a work order. It connects the energy symptom directly to the maintenance action, streamlines the whole process.
Makes maintenance far more proactive than reactive.
Totally. And data-driven, not just based on routine schedules or waiting for a breakdown.
What about the people side? We've talked tech and systems, but getting staff to change behavior, turn off lights, optimize schedules, that's always a challenge.
It is, but visibility helps enormously. When staff can actually see, maybe on a dashboard, the immediate impact of their actions, like the energy spike when equipment is left running, it makes it real.
So Circuit Meter provides that feedback loop.
Yes. It allows managers to set clear energy benchmarks for different areas or equipment, track performance against them, and provide regular, concrete feedback. It combats that performance drift we talked about by keeping energy use front of mind.
Makes sense. Hard to argue with real-time data showing waste.
It empowers the facility managers with the facts they need to enforce policies and encourage better habits.
Okay, let's move to the final piece, which is huge for municipalities now. Climate action and sustainability reporting. Cities are making big commitments.
Huge commitments. Climate protection agreements, net zero targets, LEE certifications for buildings. It's a major driver, but promises need proof.
And proof requires data, auditable data.
Correct. And this seems to be a core strength claimed by Circuit Meter. Their system is designed to automatically convert the energy consumption data, kilowatt hours, directly into CO2e data, carbon dioxide equivalents.
So it translates electricity use into greenhouse gas emissions automatically.
Yes. This allows the municipality to quantify its GHG footprint accurately, track reductions over time, and analyze where the biggest carbon savings can be made.
That sounds crucial for reporting, obviously, but also for things like grants, right?
Absolutely. Many green grants or incentive programs demand rigorous proof of energy savings and emissions reductions. Having audit-ready data from a system like Circuit Meter makes accessing that funding much easier. It replaces estimates with verified numbers.
No more guesstimating based on utility bills and square footage.
Right. You have precise, verifiable data for reporting to council, the community, and funding bodies.
And the integration piece helps here too, connecting to ESG systems.
Definitely. ESG, environmental, social, and governance reporting is becoming standard. Having Circuit Meter data flow via API into dedicated ESG platforms or even to sophisticated spreadsheets streamlines that whole reporting process enormously.
Takes the manual calculation and potential errors out of it.
Exactly. It provides that reliable, historical data foundation needed for credible ESG tracking and reporting, making those climate commitments transparent and actually verifiable.
So summing it all up, it really feels like a move away from just paying the bills to actively managing energy.
I think that's the core shift. The aggregated black box era, where the utility bill was the beginning and end of energy information for many municipalities, is ending, or at least the tools exist to end it.
And solutions like Circuit Meter are providing that visibility needed for, well, everything we discussed. Cutting costs, predictive maintenance for reliable services, and hitting those critical climate goals.
Yeah, it connects the dots between operational efficiency, financial prudence, and environmental responsibility through granular, actionable data.
It really is striking when you think about how that lack of good, detailed data has totally held back so many energy efficiency projects globally. If you can't easily prove the ROI, the money just doesn't flow.
True. Solid M&V is key to unlocking investment.
So here's a final thought for you, our listener. If this kind of granular circuit-level monitoring provided by technologies like Circuit Meter becomes widespread in municipalities, how might that fundamentally change how cities not only manage their energy budgets, but also plan their entire energy infrastructure for resilience, grid interaction, maybe even becoming active participants in the energy market? Something to think about.
It opens up a lot of possibilities, moving from passive consumption to active management. A really interesting future.
Indeed. That was our deep dive into forensic energy management for municipalities. Thanks for joining us. We'll see you next time.
And that's it for this episode of Circuit Meter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.